Now then. Okay, 12.1 on Monday. Friday. Goodness of fit, chi-squared. Okay, I looked at your homeworks, missed questions. Make sure your hoes and haws deal with the population, not samples. Okay, the very first question, that's where a lot of people missed it because they were trying to say, the expected counts or the observed counts will equal these numbers, and those numbers were from the sample. All right, so just make sure it's the population. And then also make sure you know the definition of the p-value. Right, that was a high missed. Yeah, that one right there next to it, knucklehead. Today, 12.2. So we're going to finish up the two other chi-squared tests, homogeneity and independence. Okay, you will see how similar they are, and you'll also see how similar they are with the goodness of fit. So here we go with this lesson after I turn this on. Goodness of fit, okay? That was one sample with one variable. That's what's going to separate these different tests, okay? But like I said, I think the most missed question or the most missed part of these is which test is it? Chi-squared goodness of fit, chi-squared homogeneity, chi-squared independence. That by far is the most missed from students because the formulas are the same, the conditions are, everything's the same. The only thing difference is the actual name of it. My recommendation to you is if you aren't sure, just go ahead and say chi-squared rather than say exactly which one it is. Because if you say the wrong one, you're going to get dinged. If you don't finish it, you might get dinged. Is that fair enough of what I'm saying? If you just say it's a chi-squared test, you might get dinged, but if you say the wrong one, you are getting dinged. So if you are not sure, just say it's a chi-squared test. I'm going to give you some hints today. This is a big one, right? If it's a one sample and one variable, it's the GOF. Most students don't get confused with the GOF and the other two because of the way they look. One variable, one sample, okay? Homogeneity will be more than one sample. It could be two samples, it could be three samples, it could be four samples, but it's more than one with still one variable. That's what separates homogeneity with goodness of fit, okay? It has more than one sample. So again, that's your big key on this, big key. And then independence has more than one variable. Actually, it only has two variables. It will not have more than two. It has two variables, but one sample, okay? One sample with two variables. What's your gender? What's your favorite toy? Okay, one sample, two variables. Those are what separates the three. Again, if you ever get confused or you're not solid about it, just say it's a chi-squared test. There's no chi-squared intervals. We don't do confidence intervals with chi-squareds. We just do tests. We just do tests. This one is one we did on Friday. Here's today, okay? Conditions for all three of them are exactly the same. They're exactly the same. SRS, 10%, expected counts have to be greater than 5. Expected counts have to be greater than 5. So the conditions are exactly the same for these two as what we did on Friday. SRS, 10%, expected counts greater than 5. And you guys had some homework questions on that, and you'll have some more today. The formula is exactly the same. Chi-squared is equal to observed minus expected squared over the expected. Sum those up. The formula is exactly the same. Yay! Hypotheses are close to the same. Again, I get them from the question. All of these, I just get it from the question. It will make more sense when we look at these, right? Our best suggestion is get the actual question to get it from the actual question. Just we have to assume this. There's no difference. They are equal. They are the same. That has to be the hoe. No difference. They're equal. They're the same. That's what your hoe has to be. It has to have the equal sign. And again, however you want to say that, but that's what the hoe part has to be. And then the ha is the opposite. There is a difference. They're not equal, or they are not the same. So hoe is that right? I'm just talking about the hoe right here, okay? That's the hoe distribution. They're the same. There's no difference. They will be equal. Because sometimes the statement or the question and the problem might say, trying to prove that there's a difference. Well, the hoe, you have to assume that they're the same. There is no difference, okay? Again, I think this will make more sense as we do more of them. Does background music influence what customers buy? One experiment in a European restaurant compared 3 randomly assigned treatments. 3 treatments. Whoa. 3 treatments. So that means we're not going to do the 10%. Good enough? Just always try to remember these type of things. When you have treatments, you have volunteers, or you have an experiment, we're not doing the 10%. Okay, so there's no music, there's French music, and Italian string music. So we have 3 different variables. Or 3, I'm going to rephrase that. 3 different types of music, 1 variable. Under each condition, the researchers recorded the number of customers who ordered French, Italian, and other entrees. So we basically have food and we have music. Food and music. 2 different variables. State the null and the alternative hypotheses. Okay, so basically what we're going to do, we're trying to see, does background influence what customers buy? And my hoe is going to be, background music does not influence what customers buy. And then my ha is, background music does. Y'all okay with what I'm saying? I get it from their question. And so somewhere in there, they're going to try to prove something. Is there convincing evidence that? Normally it's written right there. So does background music influence what customers buy? Probably want to say what entree they buy or what type of food they buy. But again, we'll kind of go through something like this. There is no difference in the true, we want to talk about, we want to make sure we're talking about the population, not the sample. Do I have to mention the word true? And we should. We don't want to make sure we're talking about the sample. Again, that is a highly missed part of these, is because we go back and we start talking about samples. This has to be the population. There is no difference in the true distribution of entrees ordered at this restaurant when no music, French music, or Italian string music is played. So again, that's where we got 38 of us, and we probably can write it 38 different ways, and I think we're good. Fair enough. So she said, is it not good enough just to say the background music? I think that's okay. This is a little bit more precise. This right here is one of those, like when you end up with those halves, right? We like to bump those things up. So the shorter stuff you write, the less chances you're going to have of bumping these things up. But you don't want to write so much that you say something wrong. It's a fine line. You're with me on all that stuff, right? You guys have gotten pretty good about doing your context. You guys have gotten really good at doing your context. Some of us write too much. Some of us don't write enough, but most of us are getting exactly what we need. When you don't write enough, that hurts us. It doesn't help. It doesn't strengthen your answers. If you write too much, sometimes you write something that's wrong, which is bad. That's probably worse than not writing something. And then ha is, there is a difference. And again, I don't think you have to repeat the entire thing. Ha is the same, except there is a difference. Or I think you're okay with just saying there is a difference. I don't think, you don't have to write the exact same thing twice. Any questions about that one? Again, I can't say this enough, right? 108 different students, and I'd be surprised if all 108 of you didn't write something a little bit different right there. We got to have equal, no difference, same. That's what we got to have here. And then down here is going to be the opposite of that one. Is a difference. They're not equal. They are not the same. Okay? Everybody good? Click. Here is the data. Here's the data. Now notice the difference in this data and the data we got on last Friday. The data we got last Friday was typically one row because it was one sample and one variable. One sample with one variable. Now I have one sample with two variables. Okay? Background music and entree ordered. So they're giving it to me as a table. Two-way table. That's what they'll call a lot of these is two-way tables. Okay? So this was the non-music, this was the French music, this was the Italian, and here's the totals. There's the 243 people was a total, right? We've kind of saw these before in we saw this in chapters 2, chapters 6 with probability, right? Are they independent or not? Yada, yada, yada. Yay. Okay, good. Find the expected counts. These are the observed counts. These are the observed counts. To find the expected counts, we have to assume there's no influence on it. And if there's no influence on it, then they have to be independent. And if they're independent, then all the ratios have to be the same. In other words, whatever 99 over 243 is, better be the same as whatever this is over 84. And it's probably not right now. It better be the same as this over this and this over this, and whatever 31 over this is better be these ratios. All the ratios have to be the same. Whatever this is over this has to be the same, or excuse me, other way around. Whatever this is over this has to be the same as this over this. All the ratios have to be the same. That's independence. That's chapter 6. You don't remember any of that. It's okay. Click. 99 out of 243 has to be the same. So here's how you're going to calculate the expected counts. Here's how you're going to calculate the expected counts. If this over this has to be the same as this over this, again, let me just show you mathematically, right? X over 84. This over this has to be the same as 99 over 243. They have to be the same. And I can go a different way. I could have gone 30 over 99. I'm sorry, 84 over 243. 84 over 243 has to be the same as X over 99. Either way. But you guys know if I have a ratio or a fraction equals a fraction, you cross multiply these two, and you're going to divide by this. Yay? That's how you find the expected counts. Whatever the row total is, you're going to multiply it by the column total. Whatever the row total is, multiply it by the column total, and then divide it by the table total. Row total, column total, and divide it by the table total. That's what finds those ratios. Row total, column total, table total. Row total, column total, divided by the table total, we'll find that number. We got to do it 1, 2, 3, 4, 5, 6, 7, 8, 9 times. Because I got to find the expected counts for all of these. Okay? So if I wanted the expected counts for this French Italian right here, right? You've got to take the row total, column total, divided by the table total. And that's where they intersect is that value. Expected counts can be decimals. Expected counts can be decimals, and if they are decimals, you need to leave them as decimals. Expected counts can be decimals. One of your very first questions on a test is, what are the expected counts for, and it's going to find one, right? I could say Italian other. What are the expected counts for the Italian and other? And you're going to have to find Italian and other. Well, the Italian and other is right here, so you've got to find the row total, column total, divided by the table total. Yay? And that's not on your formula sheet. You just got to know that. You got to know that. And if you don't know that, hopefully you can set up ratios and just solve it for x. It's the same thing. This over this is the same as this times this divided by this. And if I flip-flopped it, this would have been the 99 and this would have been the 84, and I still multiply these two and divide it by this. So it doesn't matter which way you go on that. What if I don't know which one's a row or the column? It doesn't matter. The far right one and the bottom one. If I want to say far right and bottom, doesn't matter. You're multiplying the two. Any questions about that? That's the expected counts. And you've got to list all the expected counts because why? All the expected counts have to be greater than 5. Click. Here's the observed counts. There's the expected counts. If they're decimals, write the decimals. If they go on forever, you don't need to write forever. We wrote a couple of decimals. Okay? Yes?
Do we have to solve every expected count?
You don't have to. If you want full points, you have to. Because we have to list all expected counts because all the expected counts have to be greater than 5. Now, I'm going to show you a little trick. I'll show you a little trick in just a second. You need to know how to do that because, like I said, that's the first question on the test. That's typically a question on the AP test. What are the expected counts for something? And you just got to know how to do that. And most of the time they show you the formula. They don't even show you, they don't even give you the choice of the values. Y'all okay? All right, boom. As with chi-squared GOF, expected count should not be rounded. I don't know if I mentioned that per se last Friday, but we do not round expected counts. That's in the long run. So don't round expected counts. Observed counts better not be a decimal, right? Observed counts can't be a decimal. If they're a decimal, you've done something wrong because you cannot observe 6.2. You can't. You can only observe integers. Okay. Good? All observed counts will not be. There that is. Degrees of freedom is a little bit different. Okay? Degrees of freedom is a little bit different. In GOF, it's categories minus 1. GOF, it's categories minus 1. For goodness of fit, you're going to take however many rows there are and subtract 1. And however many columns there are and subtract 1. And you're going to multiply those two together. You're going to multiply those two together. Don't include the totals. Don't include the totals as a column. Backing up, I'll come back. 1, 2, 3. Don't count that. 2. 1, 2, 3. Don't count that. 2. DF is 4. Okay? Rows minus 1, columns minus 1, multiply those two together. Rows minus 1, columns minus 1, multiply the two together. Don't count the totals. Don't count the totals. So it's kind of like GOF where you have categories minus 1. It's how many categories are there? None, French, Italian minus 1. French, Italian, other minus 1. Multiply the two together. Some students, teacher one time showed me that they just like to cover up the last row and cover up the last column. I think I did that backwards, and count how many cells are left. So cover up this, and there's 4 cells left. Who cares? I don't care how you get it, but you just got to know what the DF is. Cover, and don't cover up the totals and count. Cover up the last ones that are not totals. Okay? Yay, quick, good, boom, boom, boom. Don't include the totals. Or cover up the last row and the last column and count the cells. And sometimes that's just as easy, if not easier. Yay? We pretty much know everything we need to know about the next 2. You know the DF. You know how to find the expected counts. I think that's all we need to know. We need to know how to do it on our calculator. Okay, example. Ready? For a class project, Abby and Maya wanted to know, is that Maya or Mia? Mia? Maya? Mia? Maya's M-Y-A. I teach math. Abby and Maya wanted to know gender of the interviewer could affect the response of a survey question. The subjects in their experiment were 100 males from their school. Half the males were randomly assigned. Ding, 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 ding. No 10%. Half the males were randomly assigned to be asked, would you vote for a female president by a female interviewer? The other half of the males were asked the same question by a male interviewer. The table shows the results. So here's the gender of the interviewer, male and female, which is 50-50, and here's the response, yes or no, maybe. Yes, no, or maybe. Good enough with all that? They want me to state the null and the alternative hypotheses. What would you vote for? Want to know if the gender of the interviewer could affect the response to the survey question. The gender of the interviewer will not affect the response of the survey question. Would you vote for a female? 28 of you cats and 28 different ways to write that. What'd they say? There is no difference in the true distributions of response to this question when asked by a male interviewer and when asked by a female interviewer for subjects like these. Holy cow, nobody's going to write that. That's like the perfect answer that nobody's going to write. Just make sure it does not allude to the sample. Make sure it does not allude to the sample. They like to write the word true distributions. If you can get that in there some way, that's great. If you can't, it's okay, but just make sure it doesn't allude to the sample. In this sample, there is no difference. You're way wrong already. Way wrong already. Ha, there is. Ha, there is. Questions? Y'all okay? Again, I told you that for sure. There's going to be so many different ways to write that. Just please let's have that no difference or the same or whatever you got for the whole part. And then the ha is there is. There is. Okay. Show the calculation for the expected counts in the male yes, which is this one right here. So show the calculations for the male yes. So I need to take 69 and multiply that times 50. And you can do 50 times 69. It doesn't matter. Order does not matter. And I got to divide it by 100. And whatever that equals. And you got your little calculator. What is it? 34 point. Okay. Good enough? There is a question on your test just like that. I think it's the very first multiple question.
It's a long decimal, so you can round it.
Yeah, you can round it. Yep. If it's a really long decimal, I round it to a 2 or 3. Just don't round it to an integer. Beautiful. Beautiful. Okay? I saved you a little bit of math and I did the expected counts for all of them. Okay? I did the expected counts for all of them. They want me to verify that the conditions are met. So we have an SRS. Was it randomly selected? Randomly. We don't have an SRS. Don't put SRS. They're not. We have a randomly assigned 100 males. Don't check the 10% because we randomly assigned them. We used them all. I don't care about replacement. And then all expected counts greater than 5 and show them. You got to show them. You got to show them. Okay? Please show them. You can put it in a table. You don't have to just, I just make another table. M, F, you don't have to put the totals. Yes, no, M, like Y, N, and just put those numbers. Just put it in a table, that's fine. Any questions about that? Click. Random. Treatments are randomly assigned. All expected counts are greater than 5. See table. And you can say that. But if you don't list it, you will not get the credit for this one. Don't say all expected counts are greater than 5 and don't list them. Don't say N times P is greater than 10 and not tell me what N times P is. Don't say N is greater than 30 and not tell me what N is. You gotta state what these things are. You have to prove it. You have to prove it. Earlier, we calculated the chi-squared value at 4.25. This is common. Sometimes they will tell you what the chi-squared value is. So they told me it's 4.25. And if it's 4.25, I need to know what? Mark this off, mark this off, mark this one off, and mark this one off. There's my DF of 2. DF is 2. DF equals 2. Put it down on your paper. You need to put what the DF is. 4.25, 4.25, 4.252, 4.252, 4.252, 4.252, 4.252. Wait for calculator, wait for calculator, wait for calculator. I think it's coming. 4.252, 4.252, 4.252, 4.252, 4.252, 4.252, 4.252, 4.252, 4.252, 4.252, 4.252. Please, I can't remember that. 4.252, 4.252. Good gracious. Come on! 4.252, 4.252, 4.252. Distributions. Chi-squared CDF. 4.25 to 99992. 0.11, 0.12, 0.119, 0.1194. Put whatever you want. Don't put 0.1. Actually, I guess you're okay with that, but P is high, you got to fail to reject. There is not enough evidence to suggest the gender affected the responses. There is not enough evidence to suggest the gender affected it. Click. If I used table C, you should know it's between 0.1 and 0.15, but you're not going to use table C. Just go ahead and use your calculator. So you got 0.119. You do not have to show chi-squared CDF. It's not wrong if you do. Typically, the graders will not even look at it. It's extraneous stuff. guys? Everybody okay? Good? If you want to do this problem in your calculator, which we need to know how to do, here's what you have to do for these. The only way to get a two-way table in your calculator is with a matrix. The only way to get a two-way table in your calculator is a matrix. My matrix is second x to the negative 1. I got 2 in there. I'm gonna get them out of there. I'm gonna get them out of there. Second plus delete entries. Clear all lists. I don't know where it's at. Matrix. 5. Delete. Delete. Whatever. You don't have to delete them. You can override them. Second, matrix. Edit. Names, you can't do anything with them. Edit. The first question it asks you is, what is it, a 1 by 2 or 1 by 1? And this is not a 1 by 1. I don't remember if it's a 2, what is this one, 2 by 3 or 3 by 2 or 3 by 2? And if you say, I don't remember if it's a 3 by 2 or 2 by 3, when you put in 2 by 3, it doesn't look like yours. Fair? Oh, it's not a 2 by 3, it's a 3 by 2. So I'll change this to a 3 and I'll change this to a 2. Okay? Now it looks like mine. Okay, good. That's what I want it to do. I want it to look like mine. And so I'm going to put my observed counts in here. Put my observed counts in there. Somebody give me those observed counts, please. 30, enter. That's 39. 8. 3. 1, 2. 8. Easy enough. Any questions about that? Please don't say, oh, one of them is less than 5. Who cares? This is the observed counts, right? These are the observed counts. If you ever put a decimal in here, your calculator is going to go ballistic and it's going to say error, dimension mismatch. You can't do it. It knows that the observed counts better be whole numbers, okay? Now, what's nice about this is you do not have to put in the expected counts. You don't have to, okay? Stat, tests, go down to chi-squared. This time, you're not going to do the chi-squared golf. You're going to do the first chi-squared test. This is what makes it a little bit more difficult for you guys because there's 2 different tests on here. This one was last Friday. This one's today. So when I hit enter, it's going to say the observed is matrix A. I hope that's where you put it. If you didn't put it in matrix A, you got to figure out how to put matrix B or matrix C or whichever matrix you put it there. It says the expected is matrix B. We didn't put the expected in matrix B, but when I hit calculator, guess what? Matrix B is going to be done for me. It's going to do all the expected counts for me. So when I go right here, down here to calculate, boom, there's that chi-squared value, there's the p value, and there's the df. It tells you everything you could possibly need to know. Good. Second matrix. Look, matrix B is there. If I go down to matrix B, don't edit it. You can edit it if you want to, but don't edit it. Just hit enter, and there's your expected counts. Yay? So it will do all the expected counts for you. You don't need to show it. You need to know how to find it, because it will ask you what is the expected counts for a certain cell, and it won't give it to you as a number. It's going to give it to you as the ratio. That's what you have to put on your paper, and then now you can say what? All expected counts are greater than 5. You can just do that. Okay, so her question is, I can just put this on my paper. However, I would like to put like, what was it, male and female? MF, label it. Yeah, just a quick, you don't have to label it as long as we know what it is. Most of the time, the table is going to be on your answer sheet. And so I would just label the numbers right next to it and say all expected counts are in pencil. Is that fair? Most of the time, the table is going to be on your answer document with the observed counts, not with the expected. Okay, you'll get plenty of practice for that for homeworks and things, but it's under matrices. It's under matrices. Okay? Click, click, click. Put the observed counts in matrix A. Do the test. That will give you everything you need to possibly know. When you go to matrix B, it will give you the expected counts. I went 3 years without knowing it actually did the expected counts. We did them manually. It was not fun. And one year, one student says, my matrix B is already in there, so I hope so. And they said, no, I didn't put them in there. Anyway, you can use your calculator to carry it out. There is a risk. We talked about this the other day, okay? If you just use the calculator information, guys, okay, and you mess up and you put a number in wrong, we don't know how you got it wrong. Fair enough. So their recommendation is to write out the first observed minus expected squared over the expected plus ... You don't have to write them all, but they recommend showing at least a couple of them, 1 or 2, okay? That way, if you did put something wrong in your calculator, you're showing us you know how to do it. That's why you got it wrong. If we don't see any of that stuff and you just got it wrong, we're going to just have to assume you do not know how to do it. Y'all okay? Good? Click. Next question. A Pew Research Center conducts a survey about the variety of topics in many different countries. In one survey, it wanted to investigate how residents of different countries feel about the importance of speaking the national language. Separate random samples. Separate random samples. Y'all okay? So there's more than one sample, so this is not a test of, or this is a test of independence or homogeneity. Okay, y'all good? Separate random samples. We're asked many questions, include the following. Some people say that the following things are important for truly survey country nationality, for being truly survey country nationality. Others say it's not important. How important do you think it is to be able to speak English? The two-way table summarizes the responses to this question. Do these data provide convincing evidence at the 0.05 level that the distributions of opinion about speaking English differ for Austria, UK, and the US? Yes, no, maybe? Maho. The true distributions of opinion about speaking English are the same, do not differ from residents from Australia, UK, and the US. There's where I'm getting my ho and my ha from. You just have to be careful and make sure you don't write it exactly like this one because they're trying to prove that it does, and that has to be your ha. Any question about that part of it? Click. SRSs, independent SRSs, independent random samples. 1,000 is less than 10% of all Australian residents. 1,460 is less than 10% of all UK, and 103 is less than 10% of all US. We have to separate that, okay? All expected counts are greater than 5. See the table. I haven't done it yet, but I bet they're going to be. All expected counts are greater than 5. And I'll have to write them, but I'm going to just wait until I put it on my calculator to do that. Questions about the conditions? SRS, 10% large counts. SRS, 10% large counts. Prove the large counts. Prove the large counts. Don't just write it, prove it. Pencils, pencils, pencils. Happy, happy. Click. Oh, there is no difference in the true distributions of Pa about speaking English for the different residents. There is a difference. Okay? We kind of talked about that already. This is a test for homogeneity. We need to put that somewhere. I tend to put it in my calculation. Some people put it at the very beginning. Always remember, you got to have the method. You got to have the method. And if you don't think that you don't know if it's homogeneity or independence, then just put chi-squared. But there is more than one sample, and more than one sample is homogeneity. So it's pretty obvious. However, I get it. It's a test, and you guys get nervous, and you're not too sure, and you start questioning yourselves. You're better off leaving it off. Not the entire thing. Say this is a chi-squared test. And just, oh, I forgot to put homogeneity or independence. I just forgot that part. Okay. Hope it's not on the rubric, but if it is, if you put it wrong, you're getting dinged. You're getting dinged. Click. I want to go ahead. Here's your chi-squared. I wrote one of them. ... There's the chi-squared value 68. Holy cow. There are chi-squared values that are really, really big. It's okay. It happens. DF is 6. Chi-squared is really, really, really small. Really small. In fact, it's so small, some of you knuckleheads might say it's 6.75. Please don't do that.
And we don't have to write out the x squared.
You do not. If you trust yourself with a calculator, you're going to just tell me it's 68.75. 57. Say again?
What do you want us to do?
For calculations, chi-squared, DF, p-value. I need chi-squared. Whatever your calculator gives you is all you need for calculations. You got to write them down to show that they're 5, greater than 5. Okay? You have to. You can't say all expected counts are greater than 5, see calculator. Fair enough. Got to put them down. It doesn't have to be, like I said, just a quick table. A quick table. That doesn't have to be beautiful. Yes, sir.
When you do it again, do you clear out your second matrix?
You don't. That's a great question too. You don't have to clear out your second. When you do it, it overwrites it to the correct one. Good question. Good question. I typically don't even clear them, right? I just go to matrix A and just do a new matrix. Yep. I don't even clear them out. Many students lose credit because they don't write down the expected counts. You have to write them down. Sparty, what's up? To an integer? No. No. But you can't round it to an integer. Whatever. 2, 3, 5, 4, whatever. Is that fair? That's probably okay. That's probably okay. I mean, if it's a difference between an E or a P, I'd probably go ahead and round 2. But any questions? Y'all are great questions. Great questions. Things that I always assume that are known. So matrix B does get overwritten as soon as you redo it. Expected counts should not be rounded. You can put them in as a table. Okay, we're almost done. Let's talk about independence. Talk about independence because there is no difference. No difference. None. Remember that this is two samples. I'm sorry, this is two variables, one sample. Two variables, one sample. Okay. Conditions are exactly the same. Ha 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 ha. Aw. Formula. Exactly the same. Aw. Expected counts. Exactly the same. Aw. DF. Exactly the same. Hypotheses. Almost the same. Almost the same. So let me talk about the hypothesis for just a second, okay? You assume that the variables are independent. You assume that they have no association. One of those two. They are independent or have no association. One of those two. Okay, of course, you're going to put it in the context, but that's the assumption we have to have. They are independent or they have no association. If they're independent, then they don't have an association. If they have an association, then they are dependent. Oh, yeah, okay, that makes sense. If they have an association, then they're dependent on something. If they don't have an association, then they're independent. That's what we have to assume. That's what we have to assume. Okay? The two variables are not related. Have no association, however you want to say it, one of those three. Again, I'm going to get it from their question. I'm going to get it from their question, but you have to assume the whole part is this. They're going to try to say there is an association or that they are dependent. They typically use the word association. They're going to try to say that there is an association or is there an association, and your whole has to be there's not. Okay? And then the ha is the opposite of those. The ha is the opposite of those. I'm going to get it from the question. You just have to know that this has to be the ho and this part down here has to be the ha. Just be careful. Independent, no association, no relationship, which is a little bit weird than what we're used to because we're used to saying that they are equal or they are the same, and that's a little bit different now. Okay? So that's why I say they're almost the same still. I'm still going to get it from their question, but we just have to assume this part from a ho, and then of course the ha is going to be the opposite. All right? Are people who are prone to sudden anger more likely to develop heart disease? An observational study followed a random sample of 74 people with normal blood pressure for about 4 years. Each person took the Spielberger Trait Anger Scale test. Researchers also recorded if the individual developed coronary heart disease. One sample, two variables. One sample, two variables. I'm trying to see if there's an association with anger level and CHD status. Notice how I'm doing this, right? I'm trying to see if there's an association between the two variables. In the previous one, I was not associating these two. I was trying to see if there was a relationship between the variable. Independence and homogeneity. Do these data provide convincing evidence of an association between anger level and heart disease? And your ho is these data, or they're what? There is no association between anger level and heart disease. That's what we'll put as the ho. Ha, there is an association. And everything else is exactly the same. Everything else. So you got a two-way table. You're going to put it in your matrix A. You're going to find your expected counts. You got SRSs. Everything is exactly the same. Same formula, same everything. And I guess you can probably see how you can get these confused now because they look exactly the same. The only difference is this is one sample and the other ones were more than one sample. One sample, two variables. Other one's more than one sample. Okay? Chapter 1, you read about the random experiment of winter visitors in Yellowstone National Park. Holy cow, that was chapter 1. Do you belong to an environmental club? What is your experience with snowmobiles? I remember that association. We kind of looked at that a long, long time ago. Do these data provide convincing evidence of an association between environmental club status and snowmobile experience? This is independence. This is a chi-square test of independence. It's one sample, and we got two pieces of information from each individual. It's not that hard to distinguish. However, that is the most confusing thing for students. Any questions? Clicky, click, click. We got random, we got 10%, all expected counts are greater than 5, same thing. I don't want to go through the whole deal again. There is no association, there is an association. We're going to put it in context and we're going to go to town with it. We're going to find the chi-squared value just like we did. That chi-squared is 116. Holy cow, it's huge. That gives me a really, really, really small p-value. 4.82 times 10 to the negative 26. Please don't put 4.82 as your p-value. You can put it's almost zero. You can put it's really, really, really small. If you want to put 4.82 times 10 to the negative 26, you can. But don't put 4.28. Because the p-value is low, we got to reject. There is enough evidence to suggest there is an association. Reject or fail to reject ho is or is not enough evidence for ha. If you reject, there is. If you fail to reject, there is not. I could have made a type 1 or a type 2 error. This particular one, I could have made a type 1 error. What's the consequence? I don't think there is a consequence.
So we know this is a test for which is specifically asking for evidence of an association.
That's part of it. And plus it's one sample with two variables. Fair? Yep. If they ask for an association, now sometimes they ask for an association between the two samples. Is there an association between the two samples? And then you know it's homogeneity. So again, hopefully by the end of this lesson and doing several practice questions, you don't get confused about it. This is a big tip, right? When the p-value is very, very small, the calculator will report it in scientific notation. Please just be careful of that. Please be very careful of that. Chi-squared for homogeneity and independence are very, very similar. The best way to distinguish them is to consider how the data were produced. Is it one sample or is it more than one sample? More than one sample is homogeneity. One sample is independence. One is independence. One is independence. Two or more homogeneity. Click, 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 click. Questions I'm going to ask you. GOF, homogeneity, independence. Beef distributor wishes to determine whether there is a relationship between geographic region and cut of meat. The observed counts are in the table below. Is there sufficient evidence to suggest that geographic region and beef preference are associated? Well, first of all, this looks like a table or not? Okay, that looks like a table, so it's not a GOF. We don't have one variable or one sample. We do not have one variable, one sample. So now our question is, do we have more than one variable or more than one sample? More than one variable with the same sample. So it has to be independence. Say again? Where do you live, north or south? We're asking one person, where do you live and what type of meat do you like? I'm trying to see if there's a relationship between cut of meat and where you live. Okay? It didn't do the greatest of saying each person was asked. Okay. Does your zodiac sign determine how successful you're going to be? Fortune magazine collected the zodiac signs of 256 heads of the largest 400 companies. Is there sufficient evidence to claim that successful people are more than likely to be born under some signs than others? One sample, two samples, one variable, two variables. Y'all okay? One sample, one variable, that's a GOF. That's a GOF. Try to decide how many samples there are and how many variables there are. The following data is on drinking behavior for independently chosen random samples. Homogenity. Yep. Is there a different, watch this too now, guys. This is another way. Is there appear to be a gender difference? All I'm testing is this. So if you're just testing one of the variables, it has to be homogeneity. Okay? If I'm testing this to this, that's independence. But there's more than one sample, so this one can't be. I hope, guys, you can state the hypotheses and compute the expected counts. I think that's probably the biggest thing. If you can get that, you're pretty close to being able to do all this stuff, right? State and check the random, the 10%, and the expected counts. Of course, you got to be able to do that to do this. Calculate the degrees of freedom. I don't think it's a big calculation. However, you need to know what the degrees of freedom are. I hope you can perform the entire chi-squared test for homogeneity. And I hope you can perform a chi-square test for independence. And then, of course, the big one is to choose the appropriate chi-square test given situations. Homework's assigned. I hope. I say that all the time, and sometimes it's not. I need to go here. I need to go here.